In this recording, we're going to look at the concept of independence, specifically the questions 13 and 11 from chapter 15. So you remember back in our chapter 3 when you looked at streakiness, we talked about independence. We said, if a person's shots are independent, or a team's wins or outcomes of games are independent, it means the previous shots don't affect future shots, right? Okay? You're just as likely to make a shot after a make as after a miss. What we're getting here is there some connection between two categorical variables? Have a home run by Bautista? No home run by Bautista. Does that affect the wins and losses? Or are these independent of each other? And that's what we're going to look at. Okay? So you've got your two-way table here. This is a very important concept that we're going to consider. See if we can make sense out of it together. All right, got a two-way table. We want to know what's the probability that the Blue Jays won given that he hit a home run. Okay, so we're going to consider that. So let's have you work out that probability and the probability that they won given that he did not hit a home run. So see if you can come up with those two probabilities and then play the recording when you've got your answers. Okay, so hopefully you worked out part A and B because you know now about given that. Okay, so for the first one, probability that he hit a home run, I'm just looking, probability that they won given that he hit a home run. So I'm just within this column, so that would be 17 over 25, and that's going to work out to be approximately 0.680. And then I'll use another color. If he did not hit a home run, we're in this column. Okay, so probability of winning in that column was 29 out of 56. And that works out to be approximately 0.518. Okay. If these are independent results, he should be just as likely, or they should be just as likely to win whether or not he hits a home run. So if he hits a home run, or if he doesn't hit a home run, or if we don't know if he hits a home run, if it's just a win. Okay, and so if I were to calculate the probability of win, just over on the side here, the probability of a win in general, isn't that 46 out of 81? That's this column right here, 46 out of 81. So the probability of 46 out of 81 when we go on the calculator is 4681, 568. Okay. So are these all the same? And if it is an independent set of events, these should all be the same. Okay. The probability of getting a win, probability of getting a win given a certain circumstance, or given not a certain circumstance, these should all be the same. But they're not. Okay? So these are not independent results. Okay? So we'd say because the answers to A and B are not the same, the events Blue Jays win and Bautista hits a home run are not independent. Okay? It seems like the Blue Jays are more likely to win when he hits a home run. We saw that here. 680 versus when he doesn't hit a home run, they only win about 52% of the time. Let's look at another one together. Okay? Back to our golfer Randy. Okay, now we're looking at his short game, his putting. So this first question, we don't know what's the probability that he scored par or better. Par is sort of like what is expected for a particular hole. You might hear of like a par 4. That means you're expected to get it into the hole in 4 shots. Okay. So probability they scored par or better in general, okay, would be this column, 7 out of 18. 7 out of 18. Because it didn't give us any consideration. So par or better be 7 out of 18. And because we're going to be dealing with different denominators, it's always nice to put it in terms of a decimal. It sort of levels things out for us. So that'll work out to be 0.389. Okay? And we're trying to get at this notion of, is the event scored par or better and the event took 1 or fewer putts independent? In other words, is it more likely that he scores a good score, in other words, very few strokes, if he doesn't have very many putts. So let's see how that works. Okay? Probability that in part B that he took one or fewer putts or score par or better. Now there's a couple ors there. It's a little weird, but took one or fewer putts or second event scored par or better. Okay, so in that case, one or fewer putts is 8. What haven't we considered yet in terms of his par or better? That'd be this 2 over here, right? So 8 plus 2, 10 out of a total of 18. Okay, and if I turn that into a decimal, I've got 0.556. Okay. Part C says, okay, given that he took one or fewer putts. So if it's a given that, we're going to start with he took one or fewer putts. Let me get a different color involved. Get green. One or fewer putts. So I'm just looking here. What's the probability he scored par or better? Well, that would be 5 out of 8, right? Okay, so 5 out of 8, 0.65. All right. So now we reflect. Other events scored par or better and took one or fewer putts independent. Well, if they are, the probability, of him scoring par or better, which was this 389, should be just the same whether or not he gets one or fewer putts. Okay? In other words, the probability of par, I'll just say par, or better, should equal the probability of par or better, given that he had less than or equal to one putt. Those should be equal. It shouldn't matter whether he gets one or fewer putts. So in that case, let's look at those two probabilities. They are different. In other words, he does a lot better when he gets one or fewer putts. Okay? So what we'd say is they're not the same. The events are not independent. Randy is much more likely to score par or better if he took one or fewer putts. Thanks for watching.